In this video, I'm gonna talk about integration by parts, focus on the problem type exponential function. So in the question, you probably gonna see e to the x a lot. Let's see. Formula is still same. We use the same method. So I always want to find u and the dv first, which is copy from my question and then derive my new column, apply formula, right? uv minus integral new column v du is exactly the formula. So let's see the problems. See here, e to the t's. So I know I'm gonna find u and the dv. So here I tend to put exponential function e to the t's dt at the dv position. So I simply don't need to compute the antiderivative is e to the t's, right, itself. So what is left in t, right? So put it at u. If I put these two back together, I get my question, right? t e to the t's dt, old column. So du is dt based from u. Apply formula equals uv t multiply e to the t's minus integral new column e to the t's dt. T e to the t's minus e to the t's plus c. Okay, so this problem is simple, but what we want to know is I want to put the e to the x or e to the t's at the dv position. Okay, the reason is if I put u equals e to the t's, I surely say du is still itself, right? It's still e to the t's, but dv gonna be what's left in the question. We don't want to antiderivative for there possibly could be something complicated, right? And I may make a mistake when do antiderivative. However, if I put dv equals e to the t's dt, d match up d, right? So v is simply itself. I don't need to compute. And whatever left, I'm gonna put as a u position. Whatever left from the question, right? Old column. So du is doing derivative of this. It may be complicated, but derivative is always simpler than do antiderivative, right? So that's the reason why I tend to put exponential function at the dv position. So, however, the result is as long as I see this exponential function, I tend to put it at dv. Okay. Let's see next one. Again, I know I'm gonna find u and dv. Here is e to the 3x dx, right? So v is e to the 3x by 1/3. Don't forget the chain rule. If you go back, you should find e to the 3x, right? So u is what is left in 2x, right? So du gonna be 2 dx. So apply formula equals uv 2x by e to the 3x by 1/3 minus integral new column 1/3 e to the 3x multiply 2 dx. 2 dx. Okay, simplify it. 2/3 x e to the 3x minus, I want to take the constant out, right? 2/3 e to the 3x dx. So this is equal 2/3 x e to the 3x minus 2/3 e to the 3x by 1/3. Chain rule, right? You always want to go back to see if you are right, and then plus c. So simplify 2/3 x e to the 3x minus 2/9 e to the 3x plus c. Okay, so this is my final answer. I do the same thing. I put e to the 3x at the dv position, right? See next one. Again, e to the 4x. So I want to find u and the dv. I want to put e to the 4x dx here. What is left in? X squared, right? If I put these two together, I go back to my question. X squared e to the 4x dx, right? So du is 2x dx. V is simply e to the 4x by 1/4. Okay. Apply formula equals uv. X squared by 1/4 e to the 4x minus integral new column, right? 2x by 1/4 e to the 4x dx. Simplified. X squared by 1/4x, no, e to the 4x minus these two cancel to 1/2 and take it out, x e to the 4x dx, right? So again, looks like I need to do the integration by part. So u equals dv equals, I do the same thing, okay? E to the 4x dx. I put the e to the 4x here, dv. What is left in is x. So du here is dx. V is e to the 4x by 1/4. Okay, so this equals, I'm coming from here, this is what I did. X squared by 1/4 e to the 4x minus 1/2. Copy this, copy from this constant, right? So I want to solve this integral by formula, right? uv x minus x multiply 1/4 e to the 4x minus, right, this direction, new column, 1/4 e to the 4x dx. Okay. I'm coming to here, so I want to keep copy. X squared by 1/4 e to the 4x minus 1/2. Okay. So x 1/4 e to the 4x minus, I can take this 1/4 out, right? 1/4 e to the 4x dx. Okay. I forget this. Yeah. So x 1/4 e to the 4x. Yes. So now I can multiply this 1/2 in. This 1/2 in, right? So equals x squared over 4 e to the 4x, okay, minus, this is, I multiply this in, right, x over 8, right, put the x on top, 1/2 by 1/4 e to the 4x, plus, minus, 1/8, this part, e to the 4x by 1/4, okay. So I'm getting rid of this integral, and then finally plus c. and just rewrite it. X squared divide 4 e to the 4x minus x over 8 e to the 4x plus 1 over 32 e to the 4x plus c. Okay, so this is my final answer here. So in this problem, I need to do integration by part twice, right? The first time is here, second time is here. But we don't need to remember how many times I need to do based on the question. As long as I see the exponential function, I know I put it at the dv position, and then find u, find the new column, set it up based on formula, you solve it, you see this again, you do the same thing. Exponential function at the dv position, find new column, set up formula. So as long as you compute it correctly, you can solve it. You surely can solve it. So the method is pretty fixing. We always do this, right? When I see e to the x, when I see e to the x. Let's see next one. Okay, again, I see this e to the x, and a function about x multiply a function about x, right? So integration by parts. I want to find u and the dv. dv is what? E to the x dx. U is what? What is left? Cosine x, right? du gonna be negative sine x dx. D match up D, D match up D, right? So v is simply e to the x. Okay, apply formula. This equals uv cosine x e to the x minus integral new column, right? E to the x negative sin x dx. I want to take this negative sign out, which is equal cosine x e to the x plus sin x e to the x dx. Here comes again. So integration by part. U dv. E to the x dx. I surely want to put it at dv, right? So u is what? Sin x. Put these two together. I got this part, right? Sin x e to the x dx. Du is what? Cosine x dx. Don't forget d, right? V is e to the x. So this part goes to here. Cosine x e to the x plus uv, right? Sin x e to the x. I'm solving this integral here. So uv minus integral new column. New column is here, right? E to the x cosine x dx. Okay. It looks like I need to do the integration by parts again, but let's see. My question is here, right? This is my question. So what I'm doing is trying to solve it and find the answer. So I do come to here, equals, this is my answer, right? This is my answer for the question. Question equals my answer. Answer equals what? My question, right? So I simply copy my question to right hand side, e to the x cosine x dx. Okay, so okay. Question equals answer, answer equals question. I find this part, e to the x cosine x dx, which exactly my question, right? Same with my question. And I'm very lucky to find here is a negative sign, right? Which indicates I can move this back to my right side. So I'm gonna do it. Cosine x e to the x plus sin x e to the x equals 2 multiply e to the x cosine x dx. 2 of my questions, right? So what I need to do is simply divide this 2 back to left, right? So I divide 2 here. I got my answer. This is my question. This is my answer, right? And I finally want to plus c. Okay, so this one solved. We don't need to remember this question because I know e to the x cosine x dx. I gonna solve it with this method. I copy my question and then move one part back together with my question. I know I gonna use this method, but as long as I have sense, that's fine. The method is always fixed by if I put e to the x dx at the dv position and I set up my formula. I do integration by part. When I see this again, I surely can come to here, which means as long as I have an impression that I can use this way, this method, that's fine. I can solve it. Okay. We don't really need to remember this. So a brief summary for integration by part with exponential function. I always firstly try to put e to the x dx at the dv position. Okay, so what is left here is put at u. Based on this, I find my new column setup formula. Okay, so wish this helps, and again, see you in my next video. Bye.